What's good? Welcome to Solution Stoichiometry, where we're going to look at conversions between the mass of a substance and the volume of solution that's required. In other words, we can also call those gram-volume conversions or volume-gram conversions. Let's get started, shall we? Here are the things that you need to know about solution stoichiometry. First, you need to know what concentration is. Concentration describes how much of a solute is dissolved in a given amount of solution. But then you got to know what a solute is, right? A solute is the substance that is dissolved in a solution, the thing that actually gets dissolved. We also will use molarity, which is defined as the number of moles of solute per liter of solution. Molarity is a unit of concentration. If you look at the example statement at the bottom, it says a 1 molar solution contains 1 mole of solutes dissolved in 1 liter of solution. If we take a look at the side notes, we have 1 mole of sodium chloride is equal to 58.55 grams. So if you take 1 mole of sodium chloride and you dissolve it in 1 liter of water, then you're essentially dissolving 58.55 grams of sodium in that 1 liter of water. That's what makes it a 1 molar solution, 1 mole of substance in 1 liter of water. In lab, we tend to often use volumes that are measured in milliliters, but because molarity is measured in liters, we often have to find ourselves converting from milliliters to liters and back again. Or we compensate by using 1,000 milliliters. We still need to remember that the balanced chemical equation gives us the coefficients, and the coefficients represent the number of moles that are necessary for the chemicals to react. The most common way to measure out a solution is by the volume. So because we usually measure solution volumes, we use molarity as a conversion factor between the volume and the moles. So let's begin with our first problem. We have calcium hydroxide reacting with hydrochloric acid to produce calcium chloride and water, a typical acid-base reaction. The question reads, how many liters of 1.0 molar hydrochloric acid would be required to react completely with 5 grams of calcium hydroxide? I'm going to break this down into 4 sections for you, and then we're going to combine it into the 3-step process and show you how it all comes together. So the first thing we need to do is convert the grams of calcium hydroxide to moles of calcium hydroxide. So that means we need to know the mass of calcium hydroxide, which is 40 plus 17 times 2, so 74 grams per mole. So the molar mass of calcium hydroxide, 74 grams per mole. And so we start the problem with 5.0 grams. We need to convert it to moles by putting mole on the top, 74 grams on the bottom, and thus 5 divided by 74 gives us 0.067. Really it's 68. Gotcha. All right, moles. But now we need to convert the moles of calcium hydroxide to that of hydrochloric acid. So calcium hydroxide, hydrochloric acid. So we need the molar ratio of 2 HCl is equal to 1 calcium hydroxide. I know I circled the wrong thing up top. Let's go ahead and get rid of that. Okay, calcium hydroxide and hydrochloric acid. Okay, so then if I take the same number, 0.068 moles, I need to make sure that calcium hydroxide is on the bottom, CaOH2, and 2 moles of HCl on top. That gives me 0.135 moles of the HCl, right? Beautiful, but we're still not done yet. Still not done. Let's continue. So the final step is that I got to take the moles, the 0.135 moles of HCl to liters of HCl, or hydrochloric acid, remembering that 1 liter of a 1 molar solution equals 1 mole. So that means the conversion factor here is 1 liter is equal to 1 mole. Thus, I can put 1 liter on top because that's the unit I want to go to. 1 mole on the bottom because I need to cancel that out. We're still in the business of canceling things. And so the final answer ends up being 0.135 liters of hydrochloric acid. And so now let's take all those pieces and put them together. All right, so in our first step, we started with 5 grams of calcium hydroxide. We needed to divide by the molar mass of 74 grams, 1 mole on top. Then we needed to use the molar ratio to HCl divided by the 1 calcium hydroxide. And then finally, we need to use the 1 liter per 1 mole of hydrochloric acid. And so what ends up happening is the gram cancels out and the calcium hydroxide cancels out and the mole cancels out. So you're left with the same answer, 0.135 liters of HCl, hydrochloric acid. So you can put all of these steps together. Isn't it amazing? And then here's our cleaned up version so that you can see all of the molar ratios and all the work nice and neat, because you know my handwriting looks a little messy and I'm okay with that. Pause the video if you need to clean up your work a little bit, and we'll be back with another example after this short. All right, in this next example, we have a calcium hydroxide solution. So in this next example, we're still working with the same chemical reaction. So we're going to read the question. If I combined an excess of calcium hydroxide with 75 mLs of 1.0 molar hydrochloric acid, how many grams of calcium chloride would actually be formed? Well, I'm starting with milliliters. So the first thing I need to do is always convert milliliters to liters. So 1,000 milliliters is equal to 1 liter. So if I start with 75 mLs, I need to divide by 1,000 mLs, put 1 liter on top. So this now becomes 0.075 liters. Fantastic, right? Okay. Then we got to convert the liters to moles using molarity. So let me say that, using capital M, molarity. Okay. So molarity is 1.0, which means 1 mole dissolved in 1 liter. Fantastic. So if I do that, the 0.075 liters, I'm going to convert it to moles by putting 1 mole on top and 1 liter on the bottom. Just show you how stuff is canceling out once again. And so we end up using 0.075 moles of the HCl. All right, if we continue, our starting number is 0.075 moles of HCl, and we got to convert the moles of HCl to moles of calcium chloride. Here we're going to make sure we highlight the right ones this time. So 2 HCl is equal to 1 calcium chloride. And thus, if I want to set up this ratio properly, we want to bury HCl out of the way. So 2 HCl goes here, 1 calcium chloride goes on top. And so 0.075 divided by 2 is 0.0375. And now we're talking about moles of the calcium chloride. Why? Because we just canceled out the HCl, right? Okay. So then we can take this next answer, carry that over. I'm not going to rewrite that again. And so we can use the moles of calcium chloride to find the grams of calcium chloride. Well, calcium chloride is 40 plus 2 times 35.5. So 71 plus 40 is 111 gram per mole. All right. So if we say that calcium chloride is equal to 111 gram per mole, we can now set this up so that the mole is on the bottom. 1 mole, 111 grams. So we multiply that and we get 4.2 grams of calcium chloride, CaCl2. So again, I just showed you the step-by-step process, but let's put it all together again. We're going to use the mole ratios, and what I'm going to do is I'm going to start with the 75 ml, but here's a shortcut. I can say that 1 mole, the molarity of the solution, 1 molar solution, I can just put in 1,000 mLs instead of using 1 liter. All right, and that just makes life so much easier. So this will still convert it to moles. All right. Then I still need that conversion factor to go from the hydrochloric acid to the calcium chloride. And so that ratio was 1 CaCl2 over 2 HCl. And then finally, that last conversion factor is going to use the molar mass of the calcium chloride, which was 111 grams per 1 mole. And we're going to get the same work. So 4.2 grams of calcium chloride. Fantastic. Good job if you stuck with me all the way to the end. So you can take all these steps and do them together. And of course, here's the cleaned up version for you to look at and gaze your eyes upon. Doesn't it look beautiful? Probably not. You're like, why does he think stoichiometry looks beautiful? But pause the video and correct your work as you need. At this point in time, if you feel like you understand this, then you are free to pursue academic prosperity. I'll see you on the other side of success.